Creating the definition of a Python class means writing code that allows you to put together the data and behaviors that best describe a specific concept or entity. The data in a class is represented by attributes, and the behaviors of the class are given by methods. In this tutorial, we will create together a class, part of a bigger application that provides weather forecasts. We will define the class that represents a city, including its attributes and methods. Let's get started. First of all, as part of our weather forecast application, I want to create a class that represents a city. In this specific context, a city can have different attributes. We will use the following: temperature, weather type, precipitation chance in percentage, humidity in percentage, and wind speed in kilometers per hour. We also want the city class to have a method that provides the weather summary for that city. The first step is to define a constructor. The name of the constructor method for a class in Python is init surrounded by double underscores. The first parameter taken by this method is self, that represents an instance of this class, also known as an object. As you can see, right now in the constructor of our class, we are setting the value of temperature, weather type, precipitation chance, humidity, and wind speed. A class is a template or blueprint that can be used to create objects, also called class instances. For example, we can use the class city to create two objects, one for London and one for Paris forecasts. Each object can have different values for its attributes, and is stored in a different area in memory. The self parameter is the first parameter in class methods, and it refers to an instance of a class. Let's see how we can create an object of type city. This first line creates an object called London. When we create an object, the init method of the city class is called automatically. As you can see, we are passing 5 arguments when building the object. But this doesn't match with the number of parameters accepted by the init method, that is 6. This is because the self parameter doesn't need to be specified when building an instance of a class. It automatically refers to it. The output of the first print statement is the following. It shows the reference to an object of type city and its location in memory. And here is the output of the second print statement. The dict method, surrounded by double underscores in the same way we have done with init, prints the namespace of an object. As you can see, it's a Python dictionary. Here you can see the value of the attributes that we have set using the constructor of the city class. It's also important to know that the namespace of an object can be very useful when learning about Python inheritance. If you are interested, I will include a link in the description below to explain how Python inheritance works. Now that we have defined the attribute for our class, I also want to add a method to it. I want to create a method that prints the weather summary for a specific city. I will call it print_summary. As you can see, the only parameter for this method is self, that, as we have explained before, it's used to pass the instance of our class to the method. We are basically printing the object attributes in a readable format. After creating our city object for the city of London, we can call this method using the dot notation. We will write london.print_summary. And here is the output. You can see how this method helps us create a standard way to display weather forecast for a specific city. If this method wasn't there, every developer using the city class would probably display weather informations in a different way. The 5 attributes set in the init method of our class are called instance attributes, because they belong to a specific instance of our class. The first thing I notice is that our class doesn't have an attribute for the name of the city. We will add the city_name attribute to the constructor. I've added a new parameter to the constructor called city_name, then set the value of the instance attribute city_name. I will also update the method print_summary to use the name of the city from our new instance attribute. Considering that the number of parameters required by the init method has changed, we will also have to change the way we create our object. We will also have to pass the name of the city when we create our city object. And here is the output we get from the print_summary method. Let's create another object based on the city class, this time for Rome. And now let's try to update the temperature instance attribute for the London object. I will set its value to 23, and then I will use the print_summary method to show how the value of the instance attribute temperature has changed. There are cases in which it makes sense to define attributes at class level, instead of attributes at instance level. This is what we define, a class attribute. You can read and update a class attribute using the dot notation with the class name before the dot. instead of using the name of the instance. In this example, I want to add a class attribute to our city class. Our class attribute is a list that contains valid weather types. The aim is to be able to validate the weather type passed to the constructor when we create a new object. The instances of a class have access to a class attribute, and the same applies to the class itself. Here is what I mean. I can print the value of valid weather types either using the London instance, the Rome instance, or the city class. Let's update the constructor of our class to make sure our program raises an exception if an incorrect weather type is passed by the constructor. Here's how our constructor becomes. As you can see, we raise a value error exception if the user passes an invalid weather type while creating a new object. Let's create an object with an incorrect weather type and see what happens. As expected, we get a value error back due to the invalid weather type. However, this is just an example of how instance attributes can be validated in the constructor. It doesn't prevent us from setting the value of weather type to an incorrect value outside of the constructor. Here's what I mean. I have created the Athens object using a valid weather type, and then set its value to an invalid weather type outside of the constructor without receiving any errors back. To understand how class and instance attributes work, it's important to introduce the concept of namespace applied to a Python class. A namespace is a way to create a mapping between names and objects in Python, and it's implemented using the dictionary data structure. Let's have a look at the namespaces for the class City and for the class instance London to see the difference between the two. To print the content of each namespace, we use the dot notation followed by dict surrounded by double underscore. Here is the namespace for the City class. And here is the namespace for the class instance London. We can see that the class attribute valid weather types is in the class namespace, and it's not in the instance namespace. The instance namespace only contains attributes set in the class constructor. So how can I print the value of valid weather types using the London instance if the instance namespace doesn't contain the valid weather types attribute? Here's the logic used by Python. First, look for the attribute in the instance namespace. If the attribute is not in the instance namespace, then look in the class namespace. That's where the valid weather types class attribute is found. Now, let's say we try to set the valid weather types attribute for the London class instance. What happens here? Are we changing the class attribute we have defined before? Once again, let's have a look at the namespaces for the city class and the London instance. Based on the output, the value of valid weather types in the class namespace hasn't changed. At the same time, we can see that the valid weather types attribute has been added to the instance namespace with the new value we have provided. So our assignment has added a new instance attribute to the London instance. This new attribute is not visible to other instances that continue to refer to the attribute set at class level. Let's confirm that this is the case for the Rome instance. The valid weather types attribute is not present in the Rome instance namespace, and it's resolved by the class namespace. There are different ways in which class attributes can be useful. This example can be applied to many types of applications. We want to track the number of cities for which we are providing weather forecasts, and to store this information, we can use a class attribute that gets incremented every time we create a new class instance. Let's define a class attribute called cities_number. We will increase this attribute every time we create a new instance. This means we also have to change the implementation of the init constructor. Now, let's see what happens to the value of the class attribute cities_number after the creation of two instances. As expected, the value of cities_number is incremented every time a new class instance is created. Class attributes can also be used to define constants that are referenced by instance methods for specific calculations. In this example, I want to be able to provide the temperature in Celsius and Fahrenheit. To do that, I need a way to convert the Celsius value provided by the constructor into its Fahrenheit representation. Here you can see the formula to convert the Celsius temperature, Tc, into Fahrenheit, Tf. In our class, we will define a class attribute called temperature conversion factor, whose value is 1.8, the equivalent of 9 divided by 5. We will then use this class attribute to print the Fahrenheit temperature using the print summary method. Let's find out how the updated class looks like. Considering that temperature_conversion_factor is a class attribute, to refer to it, I'm using the class name, city, followed by a dot and by the name of the attribute. If I call the print summary method for the London object, I get the following output. And this is it for this training. Well done for completing it. And if you want to copy all the code that we created in this training session, I will include for you a link in the description that includes all the code. Keep learning Python and subscribe to CodeFather so we can go through the journey of learning Python together. Thank you.